Good morning, everyone, or good afternoon, depending on where you live. Next up, we're at the first session this morning of GroupBy. We have Matan Yungman talking about performance tuning features for haters. Just kidding, for lovers. Matan, take it away.
Okay, thank you, Brett, and thanks again very much for having me, and thanks for everyone who voted to see my ugly face at this time of the day. So we'll talk about a few features of SQL Server 2016 for performance tuning or execution plan lovers. Now, there were a few sessions already talking about performance enhancements in SQL Server 2016, and I refer you to those. But what I try to do is make it as much practical as possible. So this session will be very demo heavy. So we will see this slide and this about me slide, and then just jump in to the demos. So a few words about myself. My name is Matan Yungman. I live in Israel. I'm a data platform MVP. I talk a little bit about on Twitter about SQL Server and rant about MySQL. I have to work a little bit with MySQL lately, and I don't really like it. So you can see my rants over there. I work for Madeira Data Solutions. We're a consultant and training company dealing with everything data and SQL Server development, performance tuning, BI, and so on and so on. And I also a co-host SQL Server Radio, a podcast for SQL Server professionals, alongside Guy Glanzer, who had a great session last Friday. We release 2 shows a month, and if you haven't checked it out, maybe you like it. It's a nice way to learn while you're doing other things like jogging or commuting to work or washing the dishes and so on and so on. We also had two shows with Rand, which were very good, I believe. So if you haven't checked that, check it out. And without further ado, let's jump to the first demo. Where is it? Okay. So what we're doing over here is we have a relatively simple query where we use a row number in order to get all of the rows which have a rank of 1 according to some partition by that. It doesn't matter too much what the query does. And what we'll do over here, we'll start running it, and we'll make sure to enable live query statistics. What live query statistics means is, once I start running the query, is that I see the rows starting to flow between the operators in the execution plan. And what I can see here is that for each and every operator that started to work, that started to get rows, I see how much time the operator is working, and the amount of percent that this operator already handled compared to the estimated number of rows SQL Server thinks it should handle in this plan. And this is something I've blogged about in the past. I also wrote a very ugly utility a few years ago. Maybe we'll talk about it a little later. And this is something that can help us mitigate execution plan problems which were quite hard to mitigate a few years ago. So this query is about to finish, but I will stop it and execute it again because I want to show you something in this plan. So another nice thing about live query statistics, or LQS, is that it also teaches you a few things about execution plans. If you see here, those 2 operators, the table scan and the parallelism, started to work and started generating rows to the sort operator. And the sort operator, if you can see, doesn't send the rows to the operators that are after it in the execution plan. And this is because the sort operator is something that it's called a blocking operator or an iterator. And this means that it has to get all of the rows from the previous operators, and only after it gets all of the rows, it sends the rows onward in the execution plan. So if we, so now the query finished again, but as we can see, the sort blocks the rows, and after sort, and after, actually, it's not after the sort is finished, but only after the sort gets all of the rows, it started generating chunks of sorted rows onward in the execution plan. So as we understand, we have some problem in the sort, and now let's think how can we solve that. So the query ran for 52 seconds, and what we can do is this pattern of row number over partition by transaction date and order by quantity kind of hints that if we create an index on the transaction date and the quantity, maybe it will help us mitigate the sort operator. So, so if you create an index on the transaction date and quantity, and it will take about 30 seconds. And meanwhile, we can talk about the fact that we can also see live query statistics using Activity Monitor. So if we go to over here to Object Explorer and right-click on our server and go to Activity Monitor, here we can see active expensive queries. And when our query will run, we will see our query over here. Now we can see that we have a create index, and we can see show live execution plan. There isn't too much to see in the case of creating an index, but when we will have an actual plan that is running, we will see the rows flowing between the operators. Now, we have two types of profiling for the live query statistics. One is called lightweight profiling, and one is called full profiling or something like that. The full profiling means that we will get the full profiling only for queries which we enabled include actual execution plan or include live query statistics, or we gather the actual execution plan using profiler or extended events. Now, this type of profiling is generates a very big overhead on SQL Server, and that's why in SQL Server 2016 Service Pack 1, the product team developed something that is called lightweight profiling, and you can enable that by enabling trace flag 7412 at the global level of the server. So if you go here to the SQL Server service, you go to startup parameters, and you can see -T7412. You have to restart the SQL Server service, and starting from this point, you will have lightweight profiling on your server, and you'll be able to see in Activity Monitor the live execution plan, live query statistics. And just to show you, we will run this query again. And we will not include live query statistics. And we will not include the actual execution plan. And we will go to Activity Monitor, and we will close that and open that again. And we will be able to see live execution plan. Yay! And as we can see, we don't have the sort at all. Excuse me, Brent?
No, I didn't know that.
Did you say something?
Can you turn it on the like per session level outside, or you just have to turn it on across the entire server?
So you have to do it globally. I guess you can do that also by using DBCC trace on, but then when you have a restart, so it won't work. So you have to do it at the global level. What the product team says is that it's an overhead of only about 2%. So for most systems, most systems can handle that, I guess.
That's cool. Lots of people excited about that in Slack.
Yeah, this is very, very nice, and a very nice tool for the DBA, and we will talk about it in a bit. Now, I like it a lot, but I still think there are a few things to improve. I will talk about it in a few minutes. So not to ruin the party. It's a great tool. So as we can see, we went down from about 52 seconds to 12 seconds using the index. This isn't new to SQL Server 2016, obviously, but there is another thing that we can do that is new to SQL Server 2016. So let's drop this index and talk about something that is called the Eject Bengal trick, and it's related. Now, Eject has many tricks. This is called the Columnstore Index Eject Bengal trick, and for that, I will spend 2 minutes talking about Columnstore indexes. This is about me. So the Columnstore index, if you talk about the traditional approach, the row store approach, and up till SQL Server 2012, where Columnstore was introduced, we didn't know we had the row store approach because this was the only approach. But starting 2012, we have the row store approach. And what row store means is that traditionally SQL Server stores rows in pages. Obviously, each page is 8K, and generally speaking, there are nuances, but generally speaking, each page holds all of the columns of a row. So let's say I want to grab only 2 columns out of a table that has 30 columns. I still have to read all of those other columns, and this is in many cases doesn't perform very well. So as we said, that data is stored row-wise, and starting SQL Server 2012, and in 2014, which was much better, and 2016, which is also much better, we have Columnstore. And Columnstore means that we separate our columns and store each one of the columns separately, and data is stored in chunks called segments, and generally speaking, each segment holds 1 million values of a certain column. And because and there are all kinds of optimizations that allow SQL Server to compress the data, and because of that, much more data fits in memory. Even if we have to read data from disk, it's much more compressed, so we have to read much less data, and so on and so on. This isn't Columnstore session. I refer you to Nico Neugebauer's blogs and presentations, and I also have a presentation about Columnstore. But what interests us for the purpose of this session is batch mode processing, and this is one of the major improvements in query processing, in the query processing mode. And what this means is that instead of even if we in SQL Server, even if we work, let's say it's not good to work row by row. So let's say we execute the query and it has to go over 1 million rows, and it returns 1,000 rows. Even though we didn't work row by row, under the hood, SQL Server did work row by row, because each one of the operators in the execution plan works on a row by row basis. SQL Server, each operator has a method in C++, I believe, called getNextRow, and it works that way. It works iteratively on each and every row, one at a time. In batch mode processing, what this means is that we take where we take chunks, we take groups of rows of 1,000 rows at a time, treat them as a vector of rows, and manipulate them all at once together. So this yields much better performance, and this is what we want to see over here. We want to see estimated execution mode of batch and actual execution mode of batch. So those were a few minutes about Columnstore, but how does this relate to our query? Our query sits on top of row store. It doesn't sit on top of Columnstore. So this is the Eject Bengal trick, And what this trick means is that in SQL Server 2016, we can create a filtered, non-clustered column store index. It's a little complicated. We have a filtered index that is a non-clustered column store index. Up till SQL Server 2014, we could create a non-clustered column store index, but it would make the table read-only. But starting SQL Server 2016, we can create, I believe, one non-clustered column store index on a table, and it won't make the table read-only. So what Eject says, I will create a non-clustered column store index, but I will make it empty. So we have a where transaction ID equals 1 and transaction ID equals -1. And obviously, none of the rows, until we have quantum computing, none of the rows can be equal to 1 and -1 at the same time. So we'll create this non-clustered column store filtered index and execute the query again. And let's just go over the runtimes. First execution 52 seconds. After creating the index for the row number, 12 seconds. And let's see now this trick. Let's see how much time it runs. 10, 11, 12. And the demo isn't working. Great.
This is how it always works.
Let's see. So we were 20 seconds. That's okay. I forgot
your compatibility level.
Yeah, so I actually made sure we were on 130, but let's try it again. Let's look at the estimated execution plan and see if we're getting what we're supposed to get. So yeah, first of all, we have the window aggregate mode, the window aggregate operator, which is exactly for those scenarios and for column store indexes. So this is a new operator in SQL Server 2016, which is optimized for those situations. And here in the sort, we do have estimated execution mode of batch. So basically, we're okay, and this is only because of the demo god. So let's run it again. But generally speaking, even though we were at 20 seconds, it was still much better than the 52 seconds we had at the start, and we didn't have to create an index because this is a big table. We don't have to create the index on the table. We'll be at around 20 seconds again. So not as good as the traditional indexing, but much better than the original state. So this is something very interesting. Now this is a hack because I would expect if this is something that is supported, I would expect Microsoft to say to give us a hint of a use column store or stuff like that, because this is going like this. But this is nice. Be very careful because it's not documented or supported. Use it in production only if you really know what you're doing, and only if you really want to do it or really need to do it. But it's nice to know that this such thing exists. Any questions up till now, Brent?
Nope, you're good. A few questions. One question in hold on a second. Let me go back and look at it because it was. Is 7412 a documented trace flag?
Yes. Microsoft did a very good job of documenting the trace flag for many years. Trace flag, even the supported trace flag were not documented, but now they are. I don't have the exact link, but you can search for it, and they have a very nice page that is documented with all the documented trace flags. Great. By the way, this was the Eject Benkan trick. Nico Neugebauer also has a trick, and I believe Nico is saying left join into an empty table with a column store index, and this will generate the same thing. So this is another trick that you can do.
Wow.
Yeah, maybe Nico can say a few words about that afterwards.
All right.
So let's continue, and let's have a look at Query Store, which is maybe the most bombastic thing in this area of performance tuning Microsoft released. So we will go over here to Object Explorer and go to Query Store, and we have a few reports over here. And we will go to top resource consuming queries. And now what we can see here is our top consuming queries from the last hour. I can go here to configure, and I can change that. We can see that we have the last hour, and I can say last 12 hours, last day, and so on and so on. And as we can see, we have the query that we've just executed. This is the top consuming query, obviously. And we can see a few, we can see all of the execution plans that this query generated. So if we go over here, we can see that this is the one with the raw mode. And if you go over here, this is the one that we had after we created the index. And if we go over here, we should have the one that we had with the batch mode. And this is a very nice way to see our executing queries and compare execution plans and start to see which plan fits the most for our queries. And let's say I see that that I have a certain query, but the execution plan that SQL Server is currently generating isn't good enough. So I can go to this query and select the plan that I want and choose, for example, force plan. In this case, I force the bad plan, but if for some reason that's what I want to do, so I can do that. And if I do that, I go back to the query window and execute the query. And even though we have the Itzig-Bengan trick and the column store trick, we won't use that, and we will have the table scan and the bad sort. As we can see over here, we have the estimated execution plan of row instead of batch execution mode. And I will just go back to Query Store and unforce the plan. Now, Query Store is much more than that. Again, I refer you to Enrico's session about that, which goes much deeper into the Query Store. But again, this is a very nice way to look at our plans. And if I will do not the last hour, but let's say the last year, I will see much more plans over here. And I believe Enrico also has a project of showing those reports in Power BI, which can be much nicer than this UI that we have in Management Studio. And I think we're done with this demo, and we'll go to the next one. So we'll open demo number 2, and I want to show another thing with live query statistics. And we have another query, and we'll drop the clean buffers. And what we have here, we declare 2 variables and execute a query on those variables, and we'll make sure to include live query statistics. And what we can see over here, if we will go here to the right side, we can see that over here in the index seek, we're way more than 100%. And this is because when using local variables, SQL Server doesn't know the values of the variables and generates some kind of a default plan that is generated out of the statistic that we have on the table. But because the execution plan isn't optimized for those specific values that are inside the variables, we can get to all kinds of those situations. As we can see, we're at 3,000% out of the number of rows that we were supposed to handle in this operator. So this is another example. And and we see that we've finished. And just as an example, we will execute the plan with the query with option recompile, which will say to SQL Server, go read the values that are inside the variables and generate the right plan. And when we do that, we can see that the plan is slightly different. SQL Server chose to first seek the big transaction history table, then sort the data, and only then perform the clustered indexing. So again, live query statistics is not only for performance tuning, it also shows us and teaches us how SQL Server executes queries and how the flow of data in the execution plan works. So again, live query statistics, a very nice tool. So how can live query statistics be better? So again, I think it's a great tool and a great job by the product team. What I would want to see in live query statistics is, first of all, today I have to hover around and I have to search for the problem. In these cases, in those plans, it was relatively easy to find the problem because I searched for the operators that started to work and the rows that started to flow, and the percent that went up and up and up. But in more complicated queries, it will be a little complicated to do that. And what I would want from the tool is for the tool to show me, to highlight in red or in yellow where is the problem, to make our lives a little easier. So hopefully the product team will hear that and make this adjustment. And another thing that I will want to see, let's say that I'm not near my computer and we have a production problem during the weekend, and after the weekend I come back and my boss tells me on Saturday at 2 o'clock there was a problem. I can't use the tool because the query isn't running anymore. So what I would want to see is the ability to replay the execution plan, and we have something like that. If someone started to play with Azure Data Lake, in Azure Data Lake, and it's a little hard to see, it was hard to find the source of that. But if we go here over at the bottom, we see job playback, and we can play the execution plan after the query has already finished. And if you go search for videos on Azure Data Lake, you will see that the operators of this execution plan will start to fill. So I think this will be a great investment for us if we will have this tool, the ability to see live query statistics when they're not live anymore. So again, an awesome tool, but I hope the product team will make it slightly better and make our lives much easier as performance tuners. Okay, so we're done with this demo, and let's continue to execution plan comparison. And another cool tool developed in SQL Server 2016, and this is actually the same query we had in the previous demo, but we will execute that. And actually, I already executed that. I will execute the good version of this query with constants, without variables. And after I execute that, excuse me, I didn't include actual execution plan. And after the query finishes, I can go to the execution plan and hit compare show plan. And when I hit that, I can select the already saved execution plan which I want to compare to. So I'll compare to the query plan with the local variable. And when we do that, in this case, SQL Server does show me where the differences are. So as we can see, this is the old query, this is the new query. In the old query, we had a clustered index seek and a nested loops and an index seek at the bottom. In the new query, we have an index seek of the big transaction history table. We have a sort, and only then we have the nested loops into the clustered index seek. And we also have the window over here. So if they go to webinar interferes, let's try it again. Compare show plan. And over here at the side, we can also see it on the plan and at the operator level. We see the differences. But even if we look only at the plan, SQL Server highlights the changes, and we can see how SQL Server chose to execute or execute the query in each case. And we can also do that using Query Store. And when we do that, we understand what's the difference in the query plans, and then we can force the query plan that is better. So again, another nice tool for execution plan lovers. Any questions, Brent, before we move on to the next demo?
Let's see. Several people said they wanted to see for live query statistics, they wanted to see performance software like, say, SQL Sentry, Spotlight, Idera, SQL DM to capture these replays too over time so that they could jump back in time and see what queries were slow at a given time.
Yeah. So I guess that's a problem because it is an overhead. You have to keep more data over time, and the question is where you keep that. And if you do that in the cloud, it's easier, but it's harder to do that on an on-prem box. But I do hope we will have this option because I think it's a very strong tool to have.
Harry says, or Doug says, are there any additional setup steps he needs to do in order to enable that plan comparison you just showed, or how does he get that?
So what you have to do is you have to save a file of. Let's do that together. Okay. So execution plan compare. We will execute the bad query. Actual execution plan. I believe you can do that with the estimated as well, but let's do that with the actual execution plan. And after it finishes, we will save that as a file, as a SQL plan file. We will do save execution plan, and we'll override the existing file. And after that, I can take a certain execution plan and compare to that file that we've just saved. So this is basically what you can do. You can't at least for now, you can't compare two plans that sit, let's say, in Query Store or in cache. You have to save one file as a file, one plan as a file, and but I hope it will be better over time. But not too bad. We just have to keep that and then compare.
And also, this is Management Studio. You're showing 2017, or I'm sorry, 2016, I believe.
Yeah, 2016. Yes.
And then there was one other one. Teddy asks, is the job playback on by default in Azure Data Lake, or is that something you have to turn on?
I don't know enough about Azure Data Lake in order to answer this question.
And Teddy was probably even hoping it was Azure SQL DB, but no, this is Azure Data Lake.
Yeah.
All right, there you go. That's all.
Great. So let's move on and talk about session wait stats. So let's close this one. And let's talk about those. So if some of the audience saw Pedro's session, great session, by the way, covering basically what we talk about in this session and more. And Pedro talked about the fact that we have much more information about, we have wait stats information inside the execution plan. If you go to an execution plan, you will see at the right at the bottom, you will see the top 5 waste states, I believe, in the plan. So this is very, very, very good in many cases. I will show a case where this is we need another approach for seeing that. So we will make sure we will use a database called data loading, and we will create a table called load me fast, and we will insert 100,000 rows into the table. So if I include the actual execution plan and go over here, I will get 100,000 instances of this execution plan. So if I go here to the properties, I can see a good amount of information about the execution plan, but I will get 100,000 of those, and it basically kills my management studio. So I need to have another approach for that. So what I will do once my management studio revives is I will use a DMV called sysdm exec session wait stats, which allows us to see wait stats information per session. So let's wait a few more seconds. Maybe we'll kill this tab and open it again. Sorry about that. Yes, I want to cancel this query. Okay, sorry about that. So let's do that again, but now without the actual execution plan. We will use the database and create a table. And we'll insert 100,000 rows into the table in a loop. And when I go to sysdm exec session wait stats, we can see that our problem is the write log wait type, which basically means we wait for writing to the transaction log. We're waiting to go to disk and write to the transaction log. And this is a relatively simple case, but obviously in production you will have very long stored procedures which will use loops and will do queries and so on and so on and so on. And you will need this information in order to see what's the most problematic part in terms of wait stats in your query. So when we have that now, this DMV resets each time the session disconnects, and it can be a little misleading. So you need to be careful with that. But if I execute this query while my query or while my process is running, we will see the information. Maybe let's execute it again and see the numbers go up. So we were at 100,000 and we're going up and up and up. So obviously this is updated while the session is running. So this is nice. And now that I know that the most problematic part of my plan is the write log wait type, then I can go here and solve the problem. And obviously this isn't a very good way for insert values into a table using a loop. So we will either use a cross join, or another way to do that is to wrap the insert, wrap the loop or the cursor, which is essentially the same in this case, wrap that in a transaction. So when we do that, we have a begin run in the beginning and a commit at the end. What we basically say to SQL Server is we will handle in the transaction. Don't open an implicit transaction for each and every one of those 100,000 rows like you do in this case. Just write that to the buffer, and when I decide, I will commit the transaction, and then you will write the rows to disk. Basically, when each time we don't use a transaction, when we insert a row into the table, SQL Server, in order to have the ability to roll back, opens an implicit transaction. So what this means is that it has to write the data to the transaction log, and the transaction log obviously sits on disk, and the disk is very slow, and that's why our inserts are slow. It's not only because we work row by row, it's because we have to go to disk for each and every row. So when we use this method, and again, use it with care, it doesn't fit for each and every situation, but when we use this method, it works much faster, and instead of running 20 seconds, it runs just 1 second. So this is one approach I use in one of our clients. The client had a stock trading platform, and the client had a stored procedure which ran many times a second and performed a very complex logic inside the cursor. So I use this method because re-architecting the cursor would take a month, and then another month to fix the bugs that we would add when converting the cursor to a set-based solution. So we just use that. We use transactions, and we wrap the cursor with transactions, and we reduced the amount of I/O we generated significantly, and things went much faster. So again, sysdm exec session wait stats gives you another view, and again, and I think the tools that the product team added in SQL Server 2016 are very good because they enrich our arsenal as performance tuners. We had very good tools previously, but now our arsenal is much better, and this is another tool that we can use. Okay, let's move on to the next demo, and the next demo is about actual number of rows read. So we open that, and we use a database called test, and what we have here is a scenario from another client where the client we have a table called stock buys, and this query goes over all of the stocks that were bought in 2010, but they want to focus on the time of day of 2 o'clock. I don't know why at 2 o'clock something happens, and this is the only hour that interests them. So we'll execute the query, and we'll include the actual execution plan. And it took 3 seconds, and when we go here, we can see if we hover over here, so we have a clustered index seek. Generally sounds good because we like seeks. We don't really like scans as a general rule of thumb. Of course, things are in many cases much more complicated, but when we go over here and we'll go to we have an estimated number of rows of almost 300,000. Actual number of rows is actually smaller, but when we go to number of rows read, we have something new in execution plan called number of rows read, and we can see that we actually read almost 3.5 million rows. So even though the number of rows that came out of the operator was relatively small, in order to decide which rows will go out of the operator, we had to read a very big amount of rows. So this is something that we didn't have, and now we have that. And this is because if we go over here, we have a seek predicate, which is the by date and time, the date. And over here we have, so at the bottom we have the seek predicate, and we have over here the predicate, the time of 2 o'clock. And SQL Server didn't know how many rows it will have to read in order to filter out the other hours that aren't 2 o'clock. And the actual number of rows read can help us understand how much data we had to read. Now, the way to solve it in this case, I won't get to that too much, is we have a few options, but one of the options is to actually use a dates table. A dates table is a system of a numbers table, and this basic only means that we insert all of the dates in all of the hours, let's say from 2000 to 2050, which we will all be retired at this year, so we don't care. And what we do is we actually filter on the dates table and then only join back to the original table. And when we do that, excuse me, I didn't show, we read 32,000 pages out of the row using out of the table using statistics.io. And when we execute using the date table, we can see that the execution time is slightly better, but the amount of I/O that we read is much less, divided by 10. So this is very nice. Again, this is a specific optimization, but the purpose of this demo was to show the actual number of rows read. Now, another thing that, if I'm already here, that I can show you is that if you go to the execution plan, and we can go to a specific operator, and we can see if you go over here to the properties, we can see more information that we had previously. For example, we have actual time statistics. We can see the actual elapsed time in milliseconds, actual elapsed CPU time in milliseconds. And we should also have, we have actual I/O statistics. And we can see the same amount of pages that we see in statistics.io over here. We can see over here in the execution plan actual logical weights. So we have much more information in the execution plan, and we can mix those tools. In this case, I actually like to see the information over here like that, but I also have another tool of that allows me to see how much I/O and time each one of those operators took. So if I have a more complex plan, I can see for each one of the iterators how much time each one of the operators took, and understand which one of the operators was the most problematic one, and to mitigate the problem. Okay, let's move on and see what we can cover in the next 5 or 10 minutes. So we actually covered demo number 6, and let's talk about a new dynamic management function that shows us DBCC input buffer. So if so everyone who knows or doesn't know, DBCC input buffer shows us the last command. If it's something we can do here, let's say I open a window and I do select star from a big product. And we will session number 54. And I do DBCC input buffer 54. And the DBCC input buffer shows me the last command that was sent to SQL Server by this session. Now, we have other options for retrieving which query is currently running, but let's say I execute a stored procedure and a certain statement inside the stored procedure is currently running. So the other ways, which we will see in a second, will show me which statement inside the stored procedure runs, but it won't show me what command was sent to SQL Server. And in many cases, I want to see this command in order to see, for example, which parameters were passed and so on. So for example, we will create a procedure called waterGradeProc, and it will execute the query we've been knowing from the start of the session. And we will execute the stored procedure. We will just check where is session 51. Okay, so we'll execute the stored procedure. and go over here, and we will do where session ID equal 51. What you can see here is a query I use many times when I do performance tuning. What this query does is it's going to sysdm exec request, which basically says which queries are currently running. I cross-apply to sysdm exec SQL text, and if I want, I can also get the query plan using sysdm exec query plan or sysdm exec text query plan, which allows us to see the execution plan on a statement-by-statement basis and not for the whole batch. So when I do that, and we will execute the stop procedure again because it already finished, we execute it again. And when we do that, using sysdm exec input buffer, which is a new function in SQL Server 2016, we can see the input buffer, this is what we executed, and the running statement and the running batch. So in our case, the input buffer was what a great proc with a parameter of 2. The current batch that is running is the stop procedure itself, and the running statement inside the stop procedure is this select. So this option allows us in one to see all of those options in a single query. Previously, we had to execute the query without the input buffer and then concatenate DBCC input buffer in a weird way, and it sometimes worked and sometimes it didn't work. And in this case, it's very, very nice because we can get all of the information together. So again, another way and another tool for performance tuning, performance tuners to perform their job better and go drink some coffee faster because they mitigated the problem faster. And let's see if we have one last demo. So the last demo of today is for sysdm exec query stats. And sysdm exec query stats stores information about the queries that run in the system, queries, stop procedure, and so on, and it stores cumulative information. And for example, and again, we use sysdm exec query stats and sysdm exec SQL text in order to get the text, and sysdm exec text query plan in order to get the execution plan. And when we do that, we see many queries. Obviously, all of the queries that we saw at the session, and we can, for example, look at the hit the query plan, and we can, for example, do order by total elapsed time divided by cost execution count as a decimal. That's something that I'd actually do, and I then divide by 1 million in order to get the time in seconds. Obviously, it doesn't matter to do it in the order by. I will do it over here in the select. And when we do that, we get the most expensive query in terms of a single execution. So this is something that I do, for example, a lot. But now we have more tools in this DMV. If we go all the way to the right, you can see that we have many new columns, and they start in total DOP, total degree of parallelism. And we have last degree of parallelism, mean degree of parallelism, and so on and so on. We have information about memory grants that were granted to the query, min query grant, max query grant, and so on and so on. And now we can use those new columns in order to have another view of our plan cache. Basically, sysdm exec query stats show information from the SQL Server plan cache. So, for example, I can see queries that the total ideal grant in kilobyte was greater than the total granted kilobyte, and this means that the query didn't get enough enough memory grant for it to execute properly. So, for example, this query should it got more memory grant would have performed better. I can do another thing. For example, I can do order by total grant in kilobyte descending, which basically gives us the most expensive queries in terms of memory grant, which can imply that this query isn't written well or grabs a lot of information and thus has to get a very big amount of memory grants. Or I can do, for example, I can order by the last grant in kilobyte multiplied by the last DOP, which gives us a plan that is very, very, very expensive, a query that is very, very expensive. And then I can use the old tools of execution plan, or for example, use a new hint that is called min grant percent or max grant percent, in order not to give or to give the query the memory grants that it needs to get in order to execute to be executed properly. And again, very good tools and new tools that allow us to be better performance tuners. And there was an interesting scenario. The Visual Studio Online team had a crisis. Yeah, Brent laughs. They had a very big crisis, and that was because of the new cardinality estimator. So for anyone who doesn't know, when you upgrade to SQL Server 2014 and you upgrade the compatibility level, SQL Server starts to work with the new cardinality estimator, which is a part of the SQL Server optimizer. And the cardinality estimator is the one that is in charge of saying how many rows will go out of each one of the operators. And the new cardinality estimator, in some cases, calculates that differently. So in many cases, it does that better. In some cases, it does that worse. And the Visual Studio Online team, and basically whatever is in Microsoft runs in high scale. They have many customers and so on. So they had a downtime because they upgraded to the new cardinal to SQL Server 2014 or 2016. But they had problems with the new cardinality estimator. So they used the max grant percent hint in order not to allow each one of those queries to get a very big amount of memory grant and thus blocking the server. And actually, the right way to do that was to use the old cardinality estimator for this specific query, but maybe Brent will say what he thinks about that in a minute, because I see you think otherwise. But in any case, they use the max grant percent, the max grant percent hint, which solve the problem. So you can use this hint as well. And I think we're done. So I will show you this beautiful slide again. Check out, feel free to contact me and check out SQL Server Radio. And let's see if we have any questions.
Perfect. So everybody go ahead and get your questions in for Matan. I want to thank you for presenting today. It was a great rundown of lists. I really believe SQL Server 2016 is an amazing release for performance tuners. And
yes,
it's one of those where when you're talking to clients about they're having performance problems on older versions of SQL servers, well, how do you explain to them if they should move up to 2016 to make your job easier as a performance tuner?
Well, mainly I need to explain them what will benefit them, because they, generally speaking, care less about me. But if I'm a DBA, I can say that I have much more tooling, and my arsenal will be much bigger, and thus the organization will have less crises, and so on, and so on, and so on. Because at the end of the day, it's an expensive product, so we have to have very good reasons why to upgrade, and this is one of them. Because if the organization will have less downtime, so it's a motivation for your manager to upgrade.
Joe says, aren't licensing costs higher in 2016? Go ahead.
You want? So they are higher. From what I know, I'm not a licensing expert, and licensing is very, very, very complicated. You can do a career out of that, but in SQL Server 2012, there was a big change in licensing. They went from licensing per socket to licensing per core, which in many cases made the product much more expensive. I don't believe there is a change between 2012 to 2014 or 2016. But the big change is that in SQL Server Service Pack 1, you have many great features that were only in Enterprise Edition. So if we look at it this way, licensing costs actually went down. So you can run Columnstore on Standard Edition, in-memory LTP, partitioning, compression, and so on. Very good list of features. By the way, something that I forgot to say during the session, lightweight profiling is supporting the one that you are able to connect to any running query is only supported installed in SQL Server 2016 SP1. So if you're running 2016 or upgrading to 2016, very recommended to jump to Service Pack 1 from the start and not move through RTM.
I have an interesting question from JD Walker. He says, so he noticed your shirt in the background. He says, where's the shirt from? And so I said, it's a SQL Saturday shirt from SQL Saturday Israel. He says, what is SQL Saturday? So explain SQL Saturday in a nutshell.
Okay, so SQL Server, it's something that is supported and started by PASS, I believe, or it was started elsewhere. So it belongs to PASS, and it's a community session. Speakers come for free to present, and almost every week there is some kind of SQL Saturday all over the world. So you have many in the US, in Europe, in South America, and we had one in Israel as well. You're not mistaken, it wasn't Saturday, so it's just a brand name, but not every SQL Saturday happens Saturday. Most of them happen in Saturday, but in Israel we have the Shabbat, and many attendees couldn't attend if it would happen in Saturday, so we had it on Thursday. But it's very easy, relatively easy to find a SQL Saturday that happens near to you, just like a user group. So check that. It's a very nice initiative by PASS, totally by the community, and lots of fun.
Yeah, you can volunteer for them. They're all over the world. You can go hit SQLSaturday.com and either sign up for one that's coming soon near you or sign up to present.
Yeah.
Astaway says, they say SQL 2016 standard SP1 has many great features, but is it chained? Astaway, I'm not sure what you mean by chained. I've never heard that before. Chained down in the data center. You may try a different word or what you're thinking of there. Another thing I've heard from people say before is I don't want to go to a version of SQL Server until Service Pack 1 hits. So now not only is it stable, but you get more features too. I've also heard people say, is it really ready to go yet? Well, remember, there's the new SQL Server 2017 has already been named, so it's coming soon.
Yes, and if we would do this session, let's say in a few months from now, maybe we'll talk about adaptive query plan and all kinds of new features in 2017. They started to move much faster than they used to.
Yeah. Astaway says, for chained, he said, in a limitation of memory and CPU. Yeah, 2016 standard is still limited to 24 cores or 128 gigs of RAM for the buffer pool. It can use more memory for things like execution plan caching too.
Yeah, and but in addition, from what I remember, you have an additional 32 gig for Columnstore and an additional 32 gig for in-memory LTP. So that's a nice hack to bypass that limit.
Mm-hmm. Mike Hillwig says in Slack, 2016 was probably the most stable RTM version we've ever seen. RTM meaning release to manufacturing, when it first came out before any cumulative updates and service packs. I'd agree with that. I would also say with a caveat that the cumulative updates in the service packs probably been the most buggy things that I've seen.
Oh, really?
Yeah,
I was just about to say that I don't wait for a service pack, but I do wait for a cumulative update 1 or 2, because in many cases, what I say to people is that Microsoft release an RTM, the Stack Overflow guys go and deploy that on the first day, get all the cool bugs. Microsoft fixes that in CO1, and then we can go and deploy to production. But I agree. I understand you saying something a little different.
You know what's funny is at Stack Overflow, they were running the one of the preview versions of 2016 before it went live. They couldn't go to RTM due to a bug. They had to wait a while before they could go out to RTM.
Yeah.
Funny how that stuff works. All right, well, thanks.
Super early adopters. So.
Oh yeah, insane. Yeah. I thought I was even grilling them. I'm like, are you going to do SQL Server 2017 on Linux? Are you going to put that into production? And they're like, well, they thought a lot about it, but doesn't sound like they're going to do it yet. All right, well, thanks everybody for hanging out with us this morning. That's Matan's session. Give Matan a big round of virtual applause. You can say thanks to him on Twitter as well. He's Matan Yungman on Twitter. His Twitter handle's there on the screen.